On August 6, 1945, this American B-29 bomber, a four-propeller plane named the Enola Gay, left the island of Tinian for Hiroshima, Japan, carrying the uranium-235 gun-type bomb named Little Boy. Little Boy was one of the first nuclear weapons tested on mankind. While the dangers and the engineering behind it were even regretted by the scientist Oppenheimer. Julius Robert Oppenheimer was born on April 22, 1904. He worked on the Manhattan Project and was often coined as the father of the atomic bomb. But the interesting part was later in his life, he fought to eliminate the production and development of nuclear weapons and died at the age of 62 in 1967. This is how the uranium projectile is launched at 300 meters per second to initiate the 4-polonium for an extra explosion placed on the tungsten carbide. We will also be looking at the nuclear fission of the neutrons explained in super simplified animations, and not to forget the different blast radius zones of this first atomic bomb. So stay tuned and don't miss a beat. As we all know, the Manhattan Project produced two different types of atomic nuclear weapons, codenamed Fat Man and Little Boy. This is the Fat Man atomic bomb is a large, heavy plutonium imploded using shaped charges as shown in the animations. While Little Boy has a less heavy uranium weapons triggered in a shotgun or gun-type designs. The Little Boy has a length of 10 feet or 3 meters with a diameter of 28 inches 71 centimeters. While the Fat Man has a length of 10 feet or 3.3 meters, but a much larger diameter of 60 inches or 1.5 meters. Comparing this to a person will help you understand its size. Even better, let's compare this to this classic American SUV. As you see, both of the nuclear weapons look small, considering the amount of destructive power packed into it. This nuclear weapon weighs around 4,898 kilograms or 10,800 pounds, while the Little Boy, as the name suggests, weighs just shy of 4,400 kilograms or 9,700 pounds. Before we dive into how this works, we have to understand the parts of the nuclear weapon. Starting from the back, these are the box tail fins meant to stabilize the bomb when dropped from this B-29 Superfortress bomber. These are the 3 electric gun primers. The primer is the device responsible for initiating the propellant combustion located here, also known as the cordate or conventional charge, that will push this projectile at an explosive force. Moving ahead, this is the projectile tungsten carbide disc. And the most important part is the uranium-235 hollow projectile rings. It weighs around 84 pounds or 38.4 kilograms. While at the front is the uranium target rings that weigh around 56.2 pounds or 25.6 kilograms. That is around 145.5 pounds or 65.5 kilograms of uranium. Closely note, as it is very important to understand, the projectile ring slugs are hollowed and designed for the target rings to enter. All these mechanisms and parts are encased in a 6.5-inch or 170mm smoothbore gun barrel. Moving to the front, this is the impact-absorbing anvil. Just above it is the tungsten carbide plug. These are the 4 polonium initiators placed on the tungsten carbide. They are kept to make sure there will be a nuclear chain reaction when it is dropped and activated. Moving to the top of the structure are the arming and fusing equipment. Let's move outside this atomic bomb to understand it better. These are the barometric sensing ports and manifolds. The barometer helps to identify the altitude at which the bomb is located so that it can activate this Archie fusing radar altimeter, which is these curvy-looking objects that activates before reaching the ground. Just above it is the electric plug, and some refer to this as the arming wires. All that destructive power requires a platform to transport this nuclear weapon. The answer is this B-29 Superfortress. It was also the world's heaviest production plane because of increases in range, bomb load, and defensive requirements. Boeing built a total of 2,766 B-29's Superfortress planes, and it was the most advanced 4-propeller-driven bomber of the Second World War. It has a length of 99 feet or 30.1 meters, with a huge span of around 141 feet 3 inches or 43 meters. Interestingly, the plane has a gross weight of around 140,000 pounds or 63,502 kilograms and could carry a 20,000-pound bomb. The bomb bay door is located just below the fuselage, and it can open them as shown in the animations. As stated, this is one of the most fortified planes in that era. It can carry around 12, 50 caliber machine guns and remote-controlled turrets as shown in the animation. 2 below the plane, 4 above the fuselage, 2 remote-controlled turret, 1 above and below near the tail. And the last 2 are located at the back of the plane, and that is 1 protected gunship. Now that we've established the B-29 Superfortress as a primary transport, let's take a look at how this nuclear bomb works in basic step-by-step format. Step number 1. Before opening the bomb bay doors, all 3 arming plugs are pulled one after the other by the weaponeer William Sterling Deke Parsons. Step number 2. The doors open and the bomb falls due to gravity. Then it switches to its internal 24-volt battery and starts the timer. After 15 seconds, the bomb would be approximately 3,600 feet or 1,100 meters away from the aircraft. Step number 3. The barometer senses the desired height of around 580 meters or 1,900 feet. As the little boy was designed to be an airburst above the ground, the membrane closed a circuit activating the multiple radar altimeters located at the front of the bombs. The barometric stage was added because of a worry that external radar signals might detonate the weapon too early. Step number 4. To ensure accurate detection of final altitude, multiple radar altimeters were utilized. This process involves measuring the altitude above the ground beneath the aircraft or the little boy through the timing of radio waves travel, reflection, and return. Once the correct height was sensed, the firing switch activates. Step number 5. This ignites the 3 Navy gun primers in the breech plug. Step number 6. This sets off the charge consisting of 4 silk powder bags, each containing 2 pounds or 0.9 kilograms of cordite. Step number 7. The uranium projectile will be launched at 300 meters per second toward the opposite end of the gun barrel. Step number 8. 4 polonium initiators placed on the tungsten carbide initiate the nuclear reactions. Step number 9. This is where nuclear fission happens. The nuclei of certain heavy atoms split into smaller, lighter nuclei, releasing excess energy in the process. Let's dive a little bit deeper. The neutron strikes the nucleus and is absorbed. The absorbed neutron causes the nucleus to undergo deformation. The nucleus fission releases an average of 2 or 3 neutrons, thus creating a chain reaction, or in some words, an explosion. The blast radius can be divided into several zones. The central blast zone has a diameter of 0.36 square kilometers, which is the extent of the fireball radius. This is the epicenter and experienced almost total destruction. Severe blast damage zone extends to around 4.5 square kilometers. This has severe damage to buildings, high casualties, and widespread destruction and radiations. Moderate blast zone is about 8.7 square kilometers. Damage to buildings and radiation burn is still significant but less severe. Light damage zone is beyond the blast radius. At 11 square kilometers, here there's fires, radiation exposure, and psychological trauma affected survivors among the thousands. Let's simplify this through these animations. Once the correct height is sensed, the firing switch activates. The 3 Navy gun primers ignite the charge consisting of 4 silk powder bags, each containing 2 pounds or 0.9 kilograms of cordite. The uranium projectile is launched at 300 meters per second. At this point, 4 polonium initiators placed on the tungsten carbide initiate nuclear fission reactions. In a milliseconds, there will be an explosion damaging buildings and killing people by the thousands. We make original 4K 3D animation with 2 animators working on it full time. So please support us by subscribing and dropping in a comment, helping us to produce more exclusive engineering animations made with care, just for our valuable audience.